Hello everyone. Welcome back to my YouTube channel Chemical Adda. In today's video, we are going to solve a very important numerical problem from stoichiometry or process calculation based on combustion and fuel. Here we will understand how to calculate the percentage excess air step by step. So the question is, the OSAT analysis of the flue gases from a boiler house chimney by mole is given below. CO2 is equal to 11.4%, O2 is equal to 4.2%, N2 is equal to 84.4%. Assuming that complete combustion takes place, calculate the percentage excess air. So in this example, we are given the OSAT analysis of flue gas, which indicates that the composition is measured on a dry basis, which means that the water vapor has been removed before analysis. Then we are given that, based on this dry analysis, the flue gas is found to contain 11.4% carbon dioxide, 4.2% oxygen, and 84.4% nitrogen. Then in this example, we need to determine the percentage of excess air. Now, let's solve the example. So to solve this example, first let's take the basis as 100 kmol of dry flue gas. Hence, based on this, we can write the composition of flue gas in kilomole. CO2 is equal to 11.4 kmol, O2 is equal to 4.2 kmol, N2 is equal to 84.4 kmol. Now let's see how to calculate the percentage excess of air. So as we know, the formula for percentage excess air, or percentage excess O2, is equal to O2 in supplied air, minus theoretical oxygen, divided by theoretical oxygen, into 100. So to calculate the percentage excess air, first we need to calculate O2 in the supplied air, and then theoretical oxygen. Therefore, now first let's calculate O2 in supplied air. So as we have given that N2 in flue gas is equal to 84.4 kmol. But as we know, fuel generally contains almost no nitrogen, and nitrogen does not react during combustion. So all nitrogen present in flue gas must have entered with the air. Therefore, nitrogen originally present in the air supplied must be equal to nitrogen in flue gas, which is given as 84.4 kmol. Hence we get N2 in supplied air is equal to 84.4 kmol. Then we know that air contains 79% nitrogen and 21% oxygen by mole. Hence, their composition ratio can be written as O2 is to N2 is equal to 21 is to 79. Therefore, from this relation we can calculate O2 in supplied air, hence we get O2 in supplied air is equal to 21 by 79 into N2 in supplied air. After putting the value, we get O2 in supplied air is equal to 21 by 79 into 84.4. After solving this, we get O2 in supplied air is equal to 22.435 kmol. In this way, first term of the formula, that is, O2 in supplied air is calculated. Now let's calculate the second term, that is the theoretical O2. Hence second step is, calculate the theoretical oxygen. So as we know, the fuel that burns generally contains carbon and hydrogen, and both of these elements require oxygen to combust. So that carbon combines with oxygen to form CO2, and hydrogen combines with oxygen to form H2O. Therefore, the basic combustion balanced equations can be written as C plus O2 gives CO2, and H2 plus half O2 gives H2O. Now, let's calculate the oxygen needed for the combustion based on this reaction. So, from first reaction, we can say that for every 1 kmol of CO2, 1 kmol of O2 is consumed. In simple words, we can say that 1 kmol of O2 is used for carbon burning to produce 1 kmol of CO2. But in this example, we are given that the composition of CO2 in flue gas is equal to 11.4 kmol. Hence we can take O2 used for carbon burning is equal to 11.4 kmol. Then we are given that O2 is still present in flue gas is equal to 4.2 kmol, which should be unused. Hence we get O2 present unused in flue gas is equal to 4.2 kmol. Based on this, now we can calculate that O2 accounted. So the formula for O2 accounted is equal to O2 in CO2 plus O2 in flue gas. So as we know, O2 in CO2 is equal to 11.4 kilomole and O2 in flue gas is equal to 4.2 kilomole. Hence we can calculate O2 accounter as. After solving this, we get O2 accounted is equal to 15.6 kilomole. Now, let's calculate O2 unaccounted. So, the formula for O2 unaccounted is O2 unaccounted is equal to O2 supplied minus O2 accounted. So we already have O2 supplied is equal to 22.435 kilomole and O2 accounted is equal to 15.6 kilomole. So after putting this value, we get. Then after solving this we get O2 unaccounted is equal to 6.835 kilomole. So now, let's calculate theoretical O2. So the formula for theoretical O2 is equal to O2 used for C plus O2 unaccounted. So as we have O2 used for C is equal to 11.4 kilomole and O2 unaccounted is equal to 6.835 kilomole. So after putting the values, we get. Hence after solving this we get theoretical O2 is equal to 18.235 kilomole. In this way, we get the value of both the term for the formula of percentage excess air. That is, O2 in supplied air is equal to 22.435 kilomole and theoretical O2 is equal to 18.235 kilomole. So after putting the values of both terms in the formula of percentage excess air, we get. Then after solving this, we get. The percentage excess air is equal to 23.03. So in this way, we can calculate the percentage excess air. That's all for today's video. If you found this helpful, don't forget to like, share, and subscribe to Chemical Adda for more easy explanations of chemical engineering concepts. See you in the next video.